Avadine is a Bakersfield-based systems integrator with deep experience in SCADA and industrial IoT. Wheeler Ridge-Maricopa Water Storage District is a major irrigation district covering 230 square miles and serving over 147,000 acres, about half the area of San Antonio, Texas, of farmland with 34 pumping plants. This joint initiative included specialists from Avadine, Wheeler Ridge, Opto 22, Inductive Automation, and Canary. Together, we set out to solve problems with a 20-year-old SCADA system that could no longer meet modern performance or reliability demands.
So why did this project begin? The original SCADA system was set up from the year 2000, based on Tesco PLCs and radio polling. This system suffered from persistent communication failures and delays in data updates. Operators had to drive out to remote sites to reset equipment manually, a huge time and cost burden. In addition, the network was insecure, lacking segmentation and remote access safeguards, making it impossible to manage the system effectively from a distance. The existing system didn't provide real-time feedback, which made decision-making much slower, especially during peak irrigation season. Operators often found out about pump failures only after a reservoir had dropped, requiring urgent manual intervention. Communication failures also meant pumps didn't start in sequence, impacting water delivery. There were several design hurdles. 2 decades of ad hoc wiring left control panels full and cluttered, making retrofits risky. The existing PLC code was read-only and undocumented, which meant new code had to be written from scratch, while avoiding system downtime. Finally, operators were used to the old interface, so any new UI had to blend advanced features with familiar workflows. Wheeler Ridge had already partnered with Avadine for Lattice, a water information platform. This existing relationship helped build trust. Avadine also brought deep experience with ignition-based SCADA solutions. They were supported by active community collaboration, including Opto 22's engineering support and quick start resources from Canary and CirrusLink. The core solution included Opto 20's Groov Epic at the edge, streaming Sparkplug-B MQTT to an ignition server in a DMZ. Data was historized in Canary and visualized through ignition perspective clients. Communications were triple redundant using LTE, LoRaWAN, and fiber, with automatic failover managed by ignition gateway scripts. Development was streamlined by a library of ISA 101 styled templates, which reduced development time by 40%. Cybersecurity best practices like VLAN segmentation, VPNs, and firewalls were implemented to meet regulatory requirements. Implementation started with the most complex system, called the 5 system, which included 4 major lift stations. The initial cutover took about 2.5 days. As the team gained experience, they reduced downtime to under 6 hours per site. Old and new systems ran side by side until tag-level validation confirmed everything was ready to decommission the old system. Since going live, the district has experienced no unplanned comm fail events. Operators now have real-time visibility into tank levels, pump status, and VFD performance. They can respond instantly instead of waiting for the next data cycle. Each avoided field reset saves 2 to 3 hours of technician time. Thanks to real-time optimization and better pump sequencing, the district saw an 8% reduction in energy use. Canary's Historian and Python analytics help detect maintenance issues before they become critical, reducing unplanned downtime. Support costs dropped, and monthly board reports are now based on accurate real-time data. Wheeler Ridge OT staff are now capable of making their own updates to the system. They're exploring mobile dispatching and rolling out predictive analytics for pumps. Thanks to robust architecture and a strong knowledge base, they're ready for what comes next.
One of the things that we were wanting to really expose was the RSSI of our radio system, because communication was such a big deal. The Cambium radios didn't have an API that we could pull on, but it had SNMP. So leveraging the node red in the Epic PLC, we got the MIB file. We were able to extract uptime, RSSI, what channels being used, what the power output is, and we pulled in those critical data points from the primary and the secondary radio. Because we pulled them into the node red in the PLC, it became super easy to just transfer that data into a tag into my pack control. Now it's a tag. Well, now I can historize that tag. Now I can start to set some warnings and we're seeing issues here because RSSI is changed by this much of a threshold or whatever it is. So leveraging Node-RED on the Epic PLC became very impactful. We created these primary and secondary loops with all our communication for around the entire west side. And it was very painful because we were having comm issues because of the spanning tree was going back and forth. Every time we started having issues with spanning tree, it exposed that we had a radio problem. And we were able to go find that radio that was causing the issue and fix it. And once you got the system all solid and everything was good and we weren't having problems, the spanning tree worked perfectly. But over time we had, whether it was wind or movement of an antenna or whatever it was, whenever we would start having comm issues, we always had to disable spanning tree and keep the system to where it was just on the primary or the secondary loop. Well, because we chose Antera as our switch platform, the Antera was able to integrate with Ignition seamlessly, and we were able to write CLI commands from Ignition. What that allowed us to do is when we were having radio problems and we had to turn spanning tree off, we then would have a single point of failure because we only were using one path for the radios. But what happens if another radio goes out? You lose half of your sites. What we did was we gave the dispatch operator a button in Ignition that said, hey, if you ever have a comm failure, click this button. All that button did was it enabled the port that enabled spanning tree, and the system would come back up and route how it needed to route, and their comm would come right back. And so as we started to really try to think through what are our opportunities to leverage Ignition, leverage this PLC, leverage the Sparkplug B with the cloud application, we started to find opportunities to kind of take this whole project from a, hey, yeah, we're going to do comm, we're going to do PLC legacy, equipment upgrade, the features and functionality of Canary. So all of those things started to really transform this application and this project into something that was far beyond what Wheeler had hoped for.
This project is a model of community-based innovation, combining trusted integrators, modern tools, and strong vendor partnerships. The result is a cybersecure, scalable, and operator-friendly SCADA system that's ready for the future.